This video provides a summary of AASHTO T240 titled Effect of Heat and Air on a Moving Film of Asphalt, the Rolling Thin Film Oven Test, also known as RTFO. The RTFO test is used in SuperPave performance grading specifications to simulate short-term aging of asphalt binder during asphalt concrete production. During asphalt concrete production, asphalt binder is heated to high temperature to melt the binder and allow coating of aggregate upon mixing. These elevated temperatures lead to oxidation and volatilization, which is referred to as short-term aging. The RTFO test serves two functions. One, it provides simulated short-term aged asphalt binder for testing, and two, it allows for screening of binder susceptibility to volatile loss. When performing the RTFO test, the following safety precautions are required: a face shield, safety glasses, a lab coat, long pants, closed-toed shoes, and thermal insulated gloves. The following equipment and supplies are required for conducting the RTFO test: an RTFO oven, glass bottles, a scraper, a cooling rack, and a scale. In the RTFO test, thin films of asphalt binder are exposed to elevated temperature and airflow to simulate aging during asphalt concrete production efficiently. The mass loss of binder samples during conditioning at elevated temperature allows for measure of volatile loss during short-term aging. Residual binder after RTFO testing is used for dynamic shear rheometer characterization and used as input for the pressure aging vessel to produce simulated long-term aged binder. This test is conducted on unaged asphalt binder. The following provides a summary of steps required to perform the RTFO test. Heat the asphalt binder to be tested until the binder is sufficiently fluid to pour. Preheat the RTFO oven to 163 degrees Celsius. Label 2 RTFO bottles and measure and record their mass when empty. These are designated as the mass change bottles for which mass loss as a result of volatilization will be measured. In this example, we will only use one bottle. The mass of the empty RTFO bottle is 162.2 grams. Pour 35 plus or minus 0.5 grams of heated asphalt binder into each bottle. Turn the bottles on their side without rotating or twisting and place them on a cooling rack for 60 to 180 minutes. After cooling, weigh the two mass change bottles again. Record the mass. In this example, the mass of binder added to the empty bottle is 35 grams. Place the bottles in the preheated RTFO oven carousel and close the door to prevent heat loss. Then, start rotation of the carousel at a rate of 15 revolutions per minute. Set the airflow rate to 4,000 milliliters per minute and set a timer for 85 minutes. Upon rotation, the asphalt binder will be dispersed as a thin coating on the inside of the glass bottle, which increases exposure of the binder to heat and airflow, expediting the short-term aging process. After 85 minutes of conditioning, remove the bottles from the carousel, setting the mass change bottles aside to cool for 60 to 180 minutes. Residue from the remaining bottles should be transferred to a single container. Remove residue from each bottle by first pouring as much material as possible, then scraping the sides of the bottle to remove any remaining residue. The RTFO residue collected is used for rutting characterization in the DSR and for further aging in the PAV. After the mass change bottles have cooled, weigh the bottles and record the mass. In this example, where we are using just one bottle, the weight of the bottle plus binder after the RTFO test is 197 grams. Determine the mass loss. To do so, first determine the initial mass of binder before the RTFO test for each bottle. For our example, this was 35 grams. Then, calculate the final mass of binder after RTFO aging as the measured mass of the bottle plus binder after aging, minus the mass of the empty bottle. For our example, this is 197 minus 162.2 grams, which equals 34.8 grams. Use these values to calculate the percentage of mass loss during aging as shown on the slide. For our example, 0.6% of the binder mass was lost to volatilization during short-term aging. This binder meets the SuperPave specification, which places a maximum limit on mass loss during RTFO aging of 1%.